and basically the server will get this request and it'll see how it can process it, and if it needs to like request to other servers and stuff. Yeah. So this is what happens with that. And then the next part here is this HTTP-1.1. This is basically the HTTP version that gets used for this communication. So there's a couple of different versions that are defined. I think it's HTTP 2, if I'm not mistaken. I could be wrong with that. But essentially, this version defines it's not exactly fully important to you. It's more important for the client and the server to understand each other. As I mentioned, each version has a different set of rules. Like it might be like a slight tweak in how the request gets sent, or I don't know, like some type of like the body shouldn't be defined a certain way. Or there might be like different versions of each HTTP request. So this version is important for the server to kind of get the proper response, because then you can see, okay, this client is communicating to me with version 1.1, which means that the request body would look like this. So that's why the version here is important. And then the next thing that I want to highlight here, I don't know if I did a circle here. Did I? I did not. Okay. The next thing that I want to highlight here is these specific things here. So there's user agent post, set language, set encoding connection, blah blah. So what these are HTTP headers. So this is basically the metadata about the request. So this is not like stuff that you pass into the request body, because the stuff that you pass into the request body is concrete data about things that wouldn't really be important to like you as a person, for example, or like the data that gets passed in as headers is essentially data about the request rather than data that's getting passed in from the person that's sending in the request, if that makes sense. Kind of hard to explain, but what I'm trying to say is the headers contain the metadata, which is data about the data. So when you say here, like accept language, it says, hey, server, when you send me the response, make sure it's in English US, right? Or accept encoding, like make sure that it's either in GZIP or it's like encoding. We're not going to talk about that, but whatever. And then the host that I'm looking at is differentroadspoint.com. So that's how like these different headers define what your request should be like and define that metadata for the request. This user agent one basically determines what your browser is. So if ever you've been on a website and like it says, oh, we detect your browser version to be this, or sometimes even like we detect you're using Windows 10. This is basically what it determines that version information from. This user agent essentially just gives all that information about you. Yeah, so that's the different components of an HTTP request. Any questions so far? Cool. All right. So as it is for a request response cycle, if there's a request, there's obviously a response that gets sent. What does that response look like? Well, you can see it looks kind of similar. Again, there's a few things that I want to highlight here. So the first thing is the 200 OK. So the first thing that gets sent in the response is, of course, the version. The next thing here is the status. So what the status means is it's telling the client that the request went well. That's what the 200 says. You may have heard of like 404, error 404. That's basically an HTTP status. What that means is the resource that you're trying to locate isn't found. There's also error 500, which is internal server error, which means that something happened on our end, on the server's end, and not on the end of like whoever was requesting the data. So, for example, if like you put in something, if let's say you put in something that doesn't exist, then it would say, hey, I don't know where to find this resource 404. But let's say like you put in something, all of a sudden the server's crashed, right? Then it'd say like a 500 saying, hey, we kind of can't control what's happened. The server exploded. Sorry. And then, yeah, that's the type of information that the status provides. So this status information, the reason why this is important is because you want to make sure that when you're coding your snake, you always have this 200 OK. So even if, as Forrest was mentioning, for those who are in the Python workshop, as Forrest was mentioning, if like you don't have a move, you still want to make sure that if you don't have a safe move, you still want to make sure that you're passing in and moving at 200 OK. Otherwise, it's just going to keep moving forward, which is going to decide its path. So we want to make sure that doesn't happen. Then the next thing that gets passed in are the request headers, or sorry, response headers. So similarly to the request headers, this is metadata, data about the data that's getting sent in. So like the date, the server, when this resource was last modified, or when this request was whatever was last modified, what the content length is, so the request body, what's the length of the request body you're passing, what the content type is. So in our case, we're passing HTML, but let's say like you're requesting a PDF file, then it's say like applications.pdf. So these are like different types of files or resources that you can send. You send it through here. So this is good information for the browser to use, because if let's say you pass in a PDF and it tries to display this HTML file, like, I don't know what to do, right? So that's why the content type is quite important for the browser. And then the connection close, that's just telling that the connection is done, and you have all the information you need. And then the last part I want to highlight is the response body. So this is essentially what the browser is going to display to the user. So this would contain like your PDF code. This would contain like the code for the binary for an image. This would contain the HTML code, as you can see. Browsers are configured in a way that if it's HTML code, then it'll automatically display the HTML for you. But other things, they'll just kind of like they'll just say here's what you wanted. So that's how the response works. So this is what the server will send back. If it's a 500 error, then it might not have a response. It might have a response saying internal server error or something, or sorry, a response body. But it definitely needs to have this type of stuff just to make sure that the server is aware of what's happening. All right. So now we can move to the second part of the workshop, which is what is backend development. So you may have heard the term thrown around a lot and not really know what it means. Well, there's two important distinctions to make, which is the front end and the back end, and then full stack, which is close. So the front end is the client side, so that's what the user sees and interacts with. So this is like your web page or your any interface that you're using, any type of thing that's connected to the web. Everything that you're interacting with on your computer is considered the front end, and then everything that happens behind the scenes is the so as I kind of revealed here, the back end is the server side. So everything behind the scenes corresponds to the actual state of the system and the data. So well, the example that I was using, which is with Facebook, when you say you want to log in, the front end is going to be the Facebook UI, and then when you send in the password and email that you want to log in with, the back end is going to receive that request, and then it'll send another request to the database, which is also considered the back end. So the database is also part of the back end, the server is part of the back end. So you can see that like the back end is kind of like very data heavy, whereas the front end is very like user friendly and heavy. Yeah, so this is like an important distinction to make when you want to understand what front end and back end is. So backend basically, backend development is essentially defining the behavior of your server for certain, for like the way that your request is intended. So if I go back, so if you want to say like, okay, how should a hello.html request be responded to? That's where backend development comes in. You will code your server in a way that would say, okay, I've received this request. What do I do? All right. Okay, so for the example today, I'll be kind of going over both Python and Node very briefly, just because I want to make sure that I'm encompassing both workshops. I won't be going very code heavy. I'll be going much more like explanation of the code, if that makes sense. So what's Node.js? It's a JS runtime environment using Chrome's V8 engine. So essentially it allows JS to run locally. So what that means is Node.js uses the same engine that Chrome uses to run JavaScript. So Chrome has an engine that runs JavaScript on your browser. Similarly, Node.js has a JavaScript engine which runs JavaScript locally. And it allows the use of various libraries and frameworks. So these libraries and frameworks are what are going to open the door to you for backend development, such as I'll talk about a few frameworks, but like backend development in terms of how requests should be handled, how the database should be interacted with. So what is Express.js? It's a backend framework, essentially, and lightweight and easy to use. That's the reason why I'm kind of displaying this one. It's also the one that they use in the starter snake, in the starter snake template, I guess. So that's why I kind of want to demonstrate what CCSS is and how that works. It's essentially JavaScript that defines a certain behavior. And then Flask is a Python backend library, similar to Express in certain ways in terms of like kind of lightweight. It's easier to understand in certain aspects. Also, it's very widely used, so it's like kind of just easy to open. And also, the Python starter snake uses Flask. Okay. All right, let's get to the code. So let's see here. Now comes time to switch my stuff setup, and hopefully my computer decided the internet exists now. Oh yeah, we're good. Okay, cool. Here. Oh my god.
Are you all done? Okay, sounds good.
Okay, maybe joining like something to GitHub part a little bit.
Let's move on to the next part. I don't think we have time.
No time.
No time. Okay. Yeah, it is what it is. Okay. We don't, please? We're gonna run out of. Yep. You have napkins?
All right. Well, I've just gotten news that the workshop's short, sadly. So I won't be going through the code, sadly. I'll post like the resources on the Notion doc, so you'll be able to access this slideshow as well as the starter snakes that I was going to go through, and then basically hopefully that works out. And of course, if you have any questions, you can just reach out to Force Drive or any of the volunteers. But yeah, thank you.
All right, let's get a hand ready. Okay, so next up.